What to expect on the ACT Math section. The ACT Math section is all about efficiency. You have 60 minutes to answer 60 questions, which means you get about 1 minute per question. That's not a lot of time. So the key is knowing what types of questions will show up and having strategies in place to solve them quickly.
All right, let's jump into ACT Math. This test covers a lot: algebra, geometry, data analysis, but don't worry, we're going to focus on what you actually need to know. The key to success? Memorizing important formulas and knowing how to use them in a question. The good news is a lot of ACT Math is about recognizing patterns and applying simple strategies. Let's start with something that comes up all the time: fractions, decimals, and percents.
One of the biggest things the ACT loves to do is mix fractions, decimals, and percents in a word problem and expect you to switch between them effortlessly. If you're rusty on these conversions, let's go over the basics real quick. Fraction to decimal? Easy. Just divide the top number, numerator, by the bottom number, denominator. So, 3/4 equals 3 divided by 4 is equal to 0.75. Decimal to percent? Just multiply by 100. If you have 0.75, that's 0.75 times 100 is equal to 75%. Percent increase / decrease? This is where people usually get tripped up. The formula is new minus original times 100% \frac \text new \text original \text original times 100 %, original new minus original times 100%. It's just a fancy way of saying how much did it change compared to the original amount.
Let's look at a real ACT-style problem. A store marks up a $40 item by 25%. What's the new price? A. $45. B. $50. C. $55. D. $60. Now let's break this down. 25% of $40 means we multiply. 40 times 0.25 is equal to 10. So the price increases by $10. That means the new price is 40 plus 10 is equal to 50. The correct answer is B, $50. But here's a shortcut. Instead of calculating the increase separately, you can multiply by 1.25 in one step. 40 times 1.25 is equal to 50. This trick will save you time on the test.
Solving for x in one step and multi-step equations. Next, let's talk about solving for x. Some problems are super simple, and some take a few steps, but the goal is always the same. Isolate x. One-step equation example. Say you have this equation. X plus 5 equals 12x plus 5 equals 12 times plus 5 is equal to 12. The question is basically saying, what number plus 5 equals 12? To get x by itself, just subtract 5 from both sides. X equals 12 minus 5x equals 12. 5x equals 12 minus 5x equals 7x equals 7x equals 7. That's it. Two-step equation example. Now, let's try one that's a little harder. 3x minus 4 equals 113x. 4 equals 113 times minus 4 is equal to 11. Step 1. Get rid of the minus 4 by adding 4 to both sides. 3x equals 153x equals 153x equals 15. Step 2. Now, divide by 3 to isolate x. X equals 5x equals 5x equals 5. The answer is x equals 5. ACT-style problem. Solve for x. 4x minus 7 equals 214x. 7 equals 214 times minus 7 is equal to 21. Step 1. Add 7 to both sides. 4x equals 284x equals 284x equals 28. Step 2. Divide by 4. X equals 7x equals 7x equals 7. And that's our answer, x equals 7. Takeaway. If solving for x feels stressful, just remember these basic steps. 1. Undo addition / subtraction first. 2. Undo multiplication / division last. 3. Always do the same thing to both sides. The ACT loves to mix things up, but if you keep these steps in mind, you'll be able to break down any equation they throw at you. Let's keep going.
All right, let's talk about estimation. one of the simplest but most powerful tools you can use on the ACT. The test is multiple choice, so you don't always have to find the exact answer, just the best possible estimate. This can save time and help you avoid mistakes. How to use it? 1. Round numbers to simpler values. Instead of working with tricky numbers, make them more manageable. 2. Estimate before solving. This helps you eliminate unreasonable answer choices right away.
Example problem. What is 299 times 52 approximately? A. 14,000. B. 15,000. C. 16,000. D. 17,000. Instead of actually multiplying 299 by 52, let's round. 299 rounds to 300. 52 rounds to 50. Now multiply. 300 times 50 is equal to 15,000. That's pretty close to 16,000. And since 299 is slightly smaller than 300 while 52 is slightly bigger than 50, we expect the actual answer to be a little higher than 15,000. The best estimate is C, 16,000. This strategy is especially useful when answers are spread out like this, and a quick estimate can get you the right answer in seconds.
When it comes to geometry, memorizing key formulas is a must. The ACT won't always give you formulas, so you need to have these in your back pocket. Key formulas to know. Rectangle area, A equals LW, length times width. Perimeter P equals 2L plus 2W. Triangle area, I equals 1/2 times B times H. Circle area, I equals pi times R squared. Cylinder volume, V equals pi times R squared minus R squared times H.
Example problem. What is the area of a triangle with base 10 and height 8? A. 30. B. 40. C. 50. D. 60. We use the triangle area formula. For base equals 10 and height equal 8, the calculation should be A equals 1/2 times 10 times 8. A equals 80/2 equals 40. So the correct answer is B, 40. Quick tip. If a question doesn't mention height, but gives you two sides of a triangle, be careful. The base and height must be perpendicular to each other for the formula to work. Coordinate plane and slopes. Now let's shift to graphing and slopes. The ACT loves to test your ability to find the slope between 2 points or recognize equations of lines. Key formulas. Slope formula. M equals ys, y1 divided by x2, x1. M represents the slope of the line. The slope tells us how much the y value changes for every 1 unit increase in x. x1, y1, x underscore 1, y underscore 1, x1, y1, and x2, y2. x underscore 2, y underscore 2, x2, y2 are 2 points on the line. The subscript numbers, 1 and 2, just differentiate between the first and second points. y2 minus y1, y underscore 2. y underscore 1, y2 minus y1 is the change in y, vertical change, or rise. x2 minus x1, x underscore 2. x underscore 1, x2 minus x1 is the change in x, horizontal change, or run. The fraction rise/run describes how steep the line is. This tells you how steep a line is by comparing the vertical and horizontal change. Equation of a line. Y equals mx plus b, where y is the dependent variable output. MMM is the slope of the line. Triple X is the independent variable input. BBB is the y-intercept, the point where the line crosses the y-axis. This is the slope-intercept form, where m equals slope, b equals y-intercept, where the line crosses the y-axis.
Example problem. Find the slope between the points 2, 5, and 6, 9.
A1,
B2, C3.
D4.
Step 1. Recall the slope formula. The slope, m, of a line passing through 2 points, x1, y1, and x2, y2, is calculated using the formula. M equals y2 minus y1 divided by x2 minus x1. This formula represents the rise over run, meaning how much the y value, vertical, changes compared to the x value, horizontal. Step 2. Identify the values. From the given points, x1, y1 equals 2, 5, x2, y2 equals 6, 9. Now, plug these values into the formula. Step 3. Plug into the formula. M equals 9 minus 5 divided by 6 to 2. M equals 4 divided by 4. M equals 1. Step 4. Select the correct answer. Since we calculated that the slope is 1, the correct answer is A1. Final answer, A1. Quick tips for slopes. A positive slope means the line goes up from left to right. A negative slope means the line goes down from left to right. If the slope is 0, the line is horizontal. If the slope is undefined, the line is vertical. This kind of question is easy once you memorize the slope formula, and trust me, it'll come up. Let's keep going.
All right, let's talk about quadratics. These show up in the form of x2 plus bx plus c equals 0x caret 2 plus bx plus c equals 0x 2 plus bx plus c equals 0. Sometimes you can factor them, and other times you'll need to use the quadratic formula. Factoring strategy. Look for two numbers that multiply to CCC and add to BBB. If factoring doesn't work easily, use the quadratic formula x equals minus b plus or minus b2 minus 4ac2x equals backslash frac b backslash pm backslash sqrt b squared 4ac 2 apex equals 2a minus b plus or minus b2 minus 4ac. Let's break down some important angle rules that show up on the ACT. What to know? Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Vertical angles, opposite angles when two lines cross, are always equal. Example problem. If one angle is 40 degrees, what does it supplement? A. 120 degrees. B. 130 degrees. C. 140 degrees. D. 150 degrees. Since supplementary angles add up to 180 degrees, we subtract. 180 degree minus 40 degree equals 130 degree. So the correct answer is B, 130 degrees. Quick tip. If you see two intersecting lines, look for vertical angles. They're equal and can help you find missing angles faster. Bar graphs, pie charts, and histograms. The ACT loves to test your ability to read and interpret visual data like bar graphs, pie charts, and histograms. How to read them. Bar graphs compare values between different categories. Pie charts show percentages of a whole. Histograms look like bar graphs but show data in ranges, e.g., test scores grouped into 10-point intervals.
Example problem. A pie chart shows that 25% of students prefer soccer. If 200 students were surveyed, how many prefer soccer? A. 25. B. 50. C. 100. D. 125. We find 25% of 200 by multiplying. 200 times 0.25 is equal to 50. So the correct answer is B. 50.
Quick tip.
If a pie chart doesn't give percentages but instead shows angles, remember, percent equals angle divided by 360 by 100. This helps when you need to convert angles into percentages.
Now, let's talk about the 3 M's of statistics. What to know? Mean equals average, sum of numbers divided by count of numbers. Median equals middle number, when the numbers are in order. Mode equals the most common number, the one that appears most often.
Find the median of this data set. 2, 5, 7, 8, 10, 12. The median is the middle number in a sorted list of numbers. If there is an odd number of values, the median is simply the middle number. If there is an even number of values, the median is the average of the two middle numbers. Step 1. Identify the middle numbers. Since there are 6 numbers in even count, there is no single middle number. Instead, the median is the average of the two middle numbers. The two middle numbers are 7 and 8, since they are the third and fourth numbers in the ordered set. Step 2. Find the average of the middle numbers. 7 plus 8 divided by 2 equals 15 divided 2, which equals 7.5. Final answer. The median is 7.5, so the correct answer is B, 7.5.
Quick tip.
If the list has an odd number of values, just pick the middle one. If there are two middle numbers, take their average like we did here. This is an easy way to grab quick points on the ACT. Let's keep going. Probability basics. Probability is all about figuring out the likelihood of something happening. The formula is simple. P equals favorable outcomes / total outcomes. Let's look at a quick example. Say you have a bag of marbles with 3 red, 2 blue, and 5 green. If you reach in and randomly pull one out, what's the probability it's blue? Let's break this down step by step. 1. Find the total number of marbles. The bag contains 3 red, 2 blue, and 5 green marbles. Add them up. 3 plus 2 plus 5 is equal to 10. So, there are 10 total marbles in the bag. 2. Find the number of favorable outcomes. You want to pick a blue marble.
There are 2 blue marbles in the bag.
3. Apply the probability formula. P equals favorable outcomes / total outcomes. Plug in the numbers. P equals 2 divided by 10. Simplify. P equals 1 divided by 5. 4. Answer choice. The probability of drawing a blue marble is 1/5, which corresponds to choice B. Quick tip. Probabilities are always between 0 and 1. 0 means impossible, and 1 means certain. If your answer is greater than 1, something went wrong.
Word problems can seem tricky, but the key is translating words into equations. Let's break it down step by step.
Here's a classic example. John is 3 years older than twice Sarah's age. If Sarah is 5, how old is John? Start by defining a variable. Let S be Sarah's age and J be John's age.
The problem says
J equals 2S plus 3. Now plug in S equals 5. J equals 2, 5, plus 3 equals 10 plus 3 equals 13. So, John is 13 years old, and the correct answer is D, 13. Quick tip. Look for keywords like twice, multiplication, more than addition, and less than subtraction to help set up the equation.
Final tips and recap. Let's wrap things up with some last-minute ACT strategies. Practice ACT-style problems daily. The more you see, the faster you'll recognize patterns. Memorize key formulas. You don't want to waste time looking up area, slope, or probability rules. Use strategies like plugging in and estimation. If the problem involves variables, try testing real numbers. Manage your time wisely. You get 1 minute per question, so if something takes too long, move on and come back if you have time. Most importantly, stay calm and trust your preparation. You got this.